Welcome back, guys. So for this new tutorial, this is a tutorial where we are going to make a stopwatch using the Nokia N5110 screen, and we are doing this because we can do it. So we went through so many tutorials that gave us the knowledge to do this one in a very quick way. So let me share with you the final output of this tutorial. As you can see, you do have the Nokia screen and with a start and some zeros. And by the end of this tutorial, you'll be really capable to do this kind of operation, like clicking here and starting a stopwatch working quite properly, and we will make the test to see if it works properly, and you can stop it if you would like to make a break, and even you can restart, of course, and you can reset when it's working, or even so you can also stop it, and oh no, you would like to reset again, and you can do it. So within this tutorial we will go through the whole program to make this happen. Stay tuned. So as usual, all the code that we are going to write together is available in GitHub, and the link is in the description below. Also, we are going to use only the C language for this tutorial, and finally the level required for this tutorial is a WeeW level, which means you should have some knowledge in the gathered in the previous tutorial. I'm putting the links for the one that there really should be a key for this tutorial to go through quite smoothly. Okay, the hardware that we are going to use in this tutorial will be obviously the STM32F1 aka Blue Pill, then a mini push button or switch. So this one will be we will use two, one for the reset and another one for start stop. And finally, we are going to use the Nokia N5110 screen to show the stopwatch. So for the tutorial, first of all, we are going to understand the stopwatch logic overview, and that's not rocket science, but at least everyone will be aligned on the same logic. Next one, we are going to understand which pin we are going to connect, and then we will start coding by kind of a reminder about interrupts. So this will be, we will quickly go and build the interrupts that we are going to use, but we will take a look to the manual for the STM32F1. Then we will start doing the reset function, after that the stop function, and finally the best for the end, we will work on the start function. Okay, so let's have a look on how the logic will work. When we start, we will start using the reset screen. So the reset screen is just having a string here showing 0, 0, 0 and star, star, star. And as soon as I push the start button, we go to the start screen, where we will have this counter increasing each time. We will be increasing until, or if I push on reset on this reset button, so I will get back again to my reset screen, or if I push stop, we will have this string or this counter stopping and having here the start waiting, and here, as you can see, if I push the start button, it will go back here and waiting, also having the stop waiting. Also for the start, this is an option we add. So if we are at the stop screen and we push reset, we go back to the reset screen. I think that's quite easy, simple, 3 screens and just some communication. Now let's jump more on the diagram. So as said, we are going to use some interrupt, and they will be really essential in the job that we are going to do. The first one is a Systick. We are going to use a Systick to have a time pointer or a counter to see how much time has been moving. And this Systick we are creating an interrupt, and each time it's activated, we are going to increment the counter. Then we need to have an interrupt connected with a reset button. So each time we click on the reset, we have to activate one variable called reset, which will take our program to a reset mode, and start to 0 means there's nothing else. Finally, if I do have this start stop button, or as I put it start here as the name of the variable, so then we will have, if start is 0, it means if we are stopping, then we are going to put start equal 1 and start the Systick that will start the counter. Else, If the start is equal to 1, then we will put it to 0 and stop the Systick. That's all. So this is the 3 main interrupt that we are going to use within our program, which is described here. It's not really like a little bit overwhelming, but what we are going to use. So first we start always using reset. After that we check if are we reset or not. So if we are not reset, we go through start here, and if we are if we have a start equal 1, we start counting. And in the counting we have to take the counter, make some calculations, so calculate the time, the second and the minutes, and we change it to the screen and then update our screen. However, the other one are quite easier. So if we are in the reset, we have 1, so what we do is reset our counters, the global counters, stop our Systick and put a reset screen. After that, and final one, if we are in the stop, we have to go here, check if we have the counter counting or not. If it's counting, we stop the counter and we just wait. We go again to here. So this will make more sense when we will start coding, but feel free to take a look again to this tutorial or this explanation, or also why not put a comment with some question. Okay, so let's go to the next one, which is the pin description. So this is the picture of the circuit that we are going to use as usual. So the pin for the Nokia screen as they are described in the previous tutorial. So all this one are the Nokia screen, and what we are adding here is these 2 beautiful bottom here. I could find the color. So the PB0 will be connected to reset function, and the variable or function, and the PB1 will be the start stop bottom. So this one, start stop, will be the red one, and the reset will be the yellow one. Okay, so we have taken a look about everything, so it's a good time to start coding, and better than setup interrupt. Okay, so before we go for the interrupt setup, let me share with you some changes for this file. So most of the file is empty. I put some comment related to the steps, but I'm adding here for the libraries the help functions. The help function is the one that we created together a few tutorials before, and this is a set of functions that will manage the strings. We will need this later on. And also there is one change that we need to go for, is to go to the Systick time. The first one is the Systick init, and we are going to change the Systick control. Instead of parallel equal, it will be just equal, and this will force our Systick interrupt to stop when we need it. Also, the Systick interrupt start function, instead of I changed here to 7.2 million, and this is because as our clock speed is 72 megahertz, which means we do have 72 million clock by second. So if we do have 7.2 million, that means we will have an interrupt every 100 millisecond, or 10% of a second. Okay, so after doing so, we can start and jump creating our interrupt function. So first of all, we have to initialize the pins. So the port B, pin 0, and we would like that would be an output of 50, and also it will be an output as a general purpose PP. Okay, same, so quickly doing the same for the pin number 1. Okay, that's good. So, and after that we are going to initialize the interrupt routine for both pins. So to do so, before even to start, so you have to disable the, not the fig, but interrupt, disable IRQ, disable, disable IRQ, and we will finish. When we will finish everything, we have to enable IRQ. I always like to put like this, so I know when my interrupt routine preparation start and ends. So to have a quick refresh, let's jump quickly to our reference manual and start. So there is always the two-step as introduced before. The first one, we have to go to the pin itself and go for the register and jump on the the external interrupt configuration, and this is the register which is connected with the general purpose input output and allow to set up it as an interrupt connection to the system. So there is 4 register, and the first one is connected to the first 3 pins for each port. So it means on this register, this byte here is connected to the PA, A, B, C, D, and until G, depends on the microcontroller, but with the pin number 0. This one will be pin number 2, pin number 3, and pin 0, 1, 2, and 3. Okay, so to set up this one, we need to go and put for this pin equal to 1, because we are using the pin, the port B, pin 0, and this one should be equal also to 1 because it's port E, pin B. Okay, so not EXTI, it's IFIO, and it will be this one, and should be parallel equal to, and this is really not a big matter, but just careful to always understand if you need to put equal or parallel equal or equal. Okay, so and you see we do have an error sign because, as I said, there is a 4 register of this and we have to use the first one, so it should disappear now. Perfect. So after that we have to configure the interrupt routine itself. So this is for the pin. We need to jump to the next one, and if we go to the interrupt EXTI to registers, so the first one we have to activate it, and this is by putting a mask on the interrupt. So we need to put to use a pin 0 and pin 1, so we have to put a mask on both of these one, so the MR0 and MR1. So this is for IMR register, and also we need to confirm if our register is triggered by a rising trigger or a falling trigger, and this means that do you want to trigger your register using your interrupt using when you push the button or when you release the button. I would rather use for the time watch are always using the starting one, the rising one. So let's go and use it. So EXTI IMR, and here is as usual equal to 0x3. Even 3 is fine, but just I used to write it. So XTI, and here for the rising trigger it's also parallel equal to 0x3. Okay, so the last steps here after you finish doing this setup of the register, you have to go for the NVIC enable IRQ and EXTI0. It's already here, and we just copy paste. So 0 for all the one for 0 pins, and we put this one for the pin number 1. Fantastic. So after that, just for testing purposes, this line should be removed after all, because we don't need to start our program with the interrupt. We will need it later, but just for testing purposes we are going to put it. So Systick Interrupt start. Okay, this is just for testing now, and we are going to use the port C pin 13 as a test. For people who just joined, the port C pin 13 in the blue pill is connected to a green LED, and this green LED is active low, which means if the pin is low, the pin will be high, the LED will be high and will be shining. So if we just initialize the pin 13, we will see it shining green or going high. So init JP PC port C pin number 13, and we would like an output, a fast output, so we can keep with a test. And also we put here equal, so as a output for the general purpose activity, and we put it as a PP. Okay, should be good. So we made most of our initializations. We are going here to put the function for the Systick setup. So to go with that, so first function we are going to use is the one where we try to work on the interrupt for the pin number 0, which will be void exti0 interrupt routine, okay, and handler. Okay, just be careful about the capital letters, sometimes it can block your code just for that. So within the handler of the interrupt routine, this is connected directly to pin 0. There is one register which is extremely important, which is the pending register, this one. So each time we do have an interrupt, what will happen is the bit related to the pin which triggered the register will go high and will become 1, and this the program will stay inside the interrupt routine until this bit got to 0. And to write the bit to get the bit to 0 as written here, this bit is cleared by writing 1, so you have to write it as 1, so this bit will be cleared. Okay, and so exti pending register, and here it's very important to put or equal 1, so not the 1 itself but or equal, because if you put just equal, it will erase all the other bits and you may have other routines going on, so just be very careful on that. So let's use this pin, the pin 0, as the one stopping the interrupt for the Systick. So we just put Systick in it, and this one will stop the interrupt. Pardon me. And after that we just copy paste here, and we put 1 here, and as we need to set to 0 the bit number 2, so this one is equal bit number 1, so we need to put 2, and here we will put a Systick interrupt start function. So what if we push, this is just made for test, just to see that all our interrupts are working properly, and then at the end void here Systick with a capital S. Just be very careful about the writing. Handler void. So what we are going to do is just to toggle the port C pin number 13. Okay, so our program should be quite simple. So when we're just starting, we will be seeing the as we already initialized the interrupt, so each time this will be toggling the pin. But after that, and this is just a way of debugging our program and to see how things are going. After that, so if I push the pin PB0, that should stop my toggling, and if I push the PB1, it should restart it. So let's just first save, and before saving, let's take a look to our program. So this is running here, but if I do this, I should start seeing this one blinking, which is exactly what we expect. And now I expect to when I push this bottom, the yellow one which is connected to PB0, to stop the toggling. So if I push, yeah, it stopped, and if I push the red one, it should restart again toggling and shining. That's perfect. So this is exactly the behavior we expected, and this is not what we are going to use for the next step, but exactly checking that our interrupt is working. So quickly, before to jump to the next step, let's create the library for this, for setting up the interrupt. So let's create here, we call it stopwatch. Let's write it all together. Okay, so stopwatch and add. So this is, we will add later, and also let's add the stopwatch.h. Okay, stopwatch here, and let's include here, go here and put, just let's, we can copy it quickly here, and let's write here. So stopwatch.h, and here including here stopwatch.h. Perfect. So let's save, and let's jump here quickly, and we will need to have some functions like the JP drive, and also actually most of the function we can put everything, like including this one here. Okay, and let's start by creating the init function. So we call stopwatch init, and there is nothing to add here, so it's just a void. So void stopwatch here, and then void. Okay, let's copy it back here, and so we are going to put like this. Okay, something is getting wrong. I have a mistake happening here. Really? So what's going on? ASCII. What means? Stopwatch is didn't save. Let's save this one. Okay. Okay, something has generated error. Maybe this one, if I remove the void. Let's check. It's referring to itself, which should not be. Okay, perfect. So let's put the void here again. Okay, so now we can copy all what we wrote in our code here. Drive. Okay, this one is not. What's happening? Drive. Because I'm using it twice and I should not. That's smart. So let's put like this, and it should be good, because I'm taking all this. Yeah, let's remove all this like this. Yep. And let's copy everything, all that we have done for the moment, all this, and put it in stopwatch init. Okay, everything went quite well. So let's take our SW init or stopwatch init here. Okay, so we initialized everything. So let's save and run to check. We will have the warning, of course, because we need to add an extra line here and an extra line here. So after we do that, if I save and there's no error, and let's, okay, if we put the code, and we should expect to stop, to go back, stop again, and go back. So we do have now all our function ready in SW init. That was all for this part. I'll see you for the next one. So now that we set up our interrupts, we can jump to the stopwatch reset function, which should be also not that complicated. Okay, let's have our first reset function, and this is about how to initialize and start our stopwatch. So what we are going to do is to take a look on a variable. Let's call it, should be unsigned short, and we will call it a stopwatch RST for reset. Okay, and we will initialize it as a 0. However, in the normal program we will be always initializing it to 1, so the program will immediately start as a reset and put everything to 0. So this function will be, so if the stopwatch RST is so if it's RST, so if it's equal to 1, then let's the first thing to do is to put it stopwatch RST to put it equal to 0. Okay, this one will be equal to 0, and this is because as soon as we finish the reset we don't need it anymore, and we have to stop Systick init. If there is any interrupt related to Systick, we have to stop it, and also initialize or reinitialize, depends on situation, our counter for the stopwatch, which is called, we will call millis, and we will put it equal to 0. So let's set up this variable. So it should be an unsigned long and millis, and initialize as equal to 0 just in case. Okay, so after that we need to start printing, but before printing better to put a clear just in case. N5110 clear, yes. And let's use, so we created in our previous tutorial the function N110 print. However, in our function print, if we go to here, so if we take a look to the print function, the print function will delete everything using this one, and then we'll add the new code. However, what we would like to have is to keep the previous what we printed and to add something. So what we are going to do is to create a new function that we will call add print here, and each time we are going to remove, so this one cleaning the string will be all removed here, so we don't need this one anymore, and we are just going to print based on a certain position. Okay, so let's copy here and add it to the H here, already placed, quite good. So let's save and put add print. Okay, and we are going to put the start position. So let's put so the first one, or the initialized number, well, let's put 2 at the row number 2, and let's move it up maybe 25 columns, and after that let's add our one, the initialized number. Okay, we are doing only until 60 minutes, but you can feel free to add hours. Okay, and after that we have to print that, like if we are in a reset mode, we're just waiting for the stopwatch to start, so we have to print also add print start. Okay, here we will put start, and it will be in column 5, and let's put it really at the beginning of our at the beginning of the row number 5. Okay, so that's really great. So we are starting with a 0, but we are putting the reset only in 1, and this reset, so now we don't need this one anymore here, and so each time we push the bottom reset, we should have this reset happening, and so which means the SW reset should be equal to 1 if it's pushed. Okay, let's save, check if there's any error or something. Nothing. So let's go back to our screen and upload. I should not see nothing because we put it our reset as a 0, but if I push here I should see my start screen. You see how easy it is? Okay, perfect. So we do here have our code clear and working. So let's create the function, the SW reset function, or let's call it okay, so if we go here, so let's close this one and okay, put here reset stopwatch. So let's call it, so it's a void, and it will, let's call SW reset, and this will be including, so let's check the variable that we are going to need. So we will need the, of course, the reset variable and also the millis. Okay, so and so the reset variable is unsigned short, and we will need to get the pointer rst, and after that we will need the unsigned long. We call it we can call it millis too, so just and this one stopwatch SW reset, so we just copy paste our code. Okay, so let's copy paste here, Control X and Control V to see if there's nothing. Okay, there's no error. Let's add the extra line and jump with this one. So here, yeah, I need to put, this is the pointer, and this one, okay, let's put it like this. This should be good. And for the millis too, we need to put the pointer. Okay, yeah, because I forgot to add the pointer to millis. Okay, so let's copy this one, put it here, add the comma, and the magic is almost there. Okay, so let's put the SW reset. Okay, and also let's add the millis. Okay, let's check now. So if we save and run, I should have this warning here because I forgot to add this one. Let's check again. No, sorry, I have to check this. Okay, no warning, but if we go here, so we already upload the code, so if I push reset, yeah, I do have it from the beginning and perfect. So now I just need to change reset to 1, so it's initialized first, so we should see this screen immediately. Let's do like this, and we do have our reset function. Okay, so the reset function is done. We can jump to the stump function and almost there. So what we are going to put, so we do have else if. So if, and we will have the SW, the stopwatch start variable that we will add equal to 0. So if this one is equal to 0, so let's set up this function. It should be also a short, same as the reset one, and will be initially set up to 0 because we don't need to start at the beginning. So if it's reset to 0, so I will need to keep it between two parentheses, and also because if this is just this one, it would be stopping always. We need to add another condition, is the counter of the Systick is different of 0. So if my counter is equal to 0, I don't really need to jump there. So let's put counter, and we will create it too. Counter, so here is different from 0. Okay, so I need to set up counter. Counter will be just an int, unsigned int. Okay, so unsigned int counter, and equal to 0, because we don't need to have any stop when we have it. And each time, so if we do have that, so the first thing is to stop the Systick. So Systick init. Then we put counter to 0. We don't need to calculate anything within the Systick itself. Okay, and finally we have to print something like putting a start. So if we do have already started the stopwatch and we push stop, we should see the start button to understand that if we push again, the stopwatch will restart. So what we will do, we just copy same as this one, as this function. Okay, and instead of start, we are going to put stop. And you can see if I don't add an empty space here, the T will stay. And actually I need to put here, no, it should be start, not stop. Stop will be for the when we start the stopwatch. Okay, so that's really good. So here we do have everything, almost everything. So what we can jump to is to go to the IRQ handler and start updating what happened when we push the start stop button. Okay, so first of all, I'm going to remove this one or comment it for the moment because we will need. So the thing is, so start and stop is toggling each time. So if start, so it means if start is equal to 1. So if start, then it's actually SW start. Okay, then so the SW start will be equal to 0. Okay, and here put else SW start or stopwatch start will be equal to 1. Equal to 1 means that we will have a stopwatch working. So which means also we need to initialize the Systick Interrup start. Okay, so and when we have to run the Systick Interrupt, what we have to do here is to start incrementing the counter variable that we created. So it will be ++. Okay, so we are almost there. So here we just click start. So now if I start, so my start will be equal to SW start is equal to 0, but my counter is not. So if I click once now in our test, so our Systick Interrupt start will start, and this one will be more than 0. So if I click again, I should see the screen when there is here a start, but we will not understand the difference. So what I will do, just for test purposes, I'm putting stop here. Okay, just to see the behavior that will happen. Okay, so we have nothing here. When I will click once, now you see here we do have the stop, and the problem, I will zoom later on, you can see that we have an extra T. So if I click here again, you see it's initialized, but here I click twice and go stop. So now if I correct it, and this is for later because here it must be start. So let's save, run, initialize to start, and if I click once, second time, it's stop. Okay, that's good. So now we have our behavior working as we expect. we can start doing our function. The function will accept, so we need to get okay, only the counter variable in this one. Okay, so let's go to the stopwatch function, and let's it's a void, and let's call it SW stop to stay with the spirit, and it's unsigned int, and we need to get it as a pointer, and we call it counter. Okay, and let's go copy paste all this. We put it inside it here, and I think we are good. If we save, so let's save, and let's take the function to the H. Okay, the header. Okay, and let's just take it and put here with, yeah, there's one thing I have to change. It's not the counter here. I need to put the asterisk, so it will take the value, not making a mistake, and this one will be counter here, so I'm passing the pointer to it. Okay, let's save, check. Okay, there's one warning, and probably this is because, okay, this is because I forgot to add an extra line here. I should have a clean code now. Yeah, perfect. Let's run again and see what would happen. Okay, so let's okay, this is a reset, so if I click once, we do have a stop, and it should stay there because for the moment there's nothing else. Let's correct before going to the next and final function. Put star here, as each time we click on the stop button we have to put the star. Right, the stop function was quick. Now the last one, the start function, which is really here we will have a lot of fun, so prepare yourself. If you want, take a look to the help function library that we created. I added the link below, so please feel free also to ask question. Okay, let's go. Okay, here we are at the start function. Yeah, the heart of our application, and let's go for it. So we are going to take exactly the same condition, but we will be doing the start function only when the stopwatch start is equal to 1. So let's delete this one and start with updating. So first thing first, we are taking this function here, and we are going to put it, and as soon as we start we have the stop option available. Okay, and also as soon as we start to, we can reset. Okay, and we are not putting the same at the same position, else this reset will erase the stop, but we will put it a little bit far, so it will give kind of a picture of a different button. Okay, good. So we could do this, but after that we have to check on millis. So millis will be plus equal cumulated on how much is the counter has moved since last time, and after that we have to reinitialize the counter, saying that we already took the number. Okay, so this is done, and after we have done that we need to count from millis how many seconds passed. So as millis happen every 100 milliseconds, so seconds will be equal to millis divided by 10. So this is the number of seconds that pass. So we didn't declare second yet. Second will not be that big number, but we will put unsigned int second, and we put equal 0 as initialization. Okay, so this is done, and after the second has been here declared, we need to know how many milliseconds we are. So millis will be a cumulated number, but just milli will be equal millis but the rest of the division or modulus of 10. So this is the number that we are going to show in our Nokia screen. Okay, after that we can know how many seconds we do have. So for second, not seconds, but the second is the number that we are going to show is seconds rest of division by 60. So this is also second, the number that we are going to show in the Nokia. So let's also copy this second. So we just copy like this. And as you would expect, we will have minutes also as an int. So let's add minute directly. Okay, so far we finished with all the testing, but let's check how the program is working and let's review how things are going. So let's take a look. So we are at restart. So let's check. There's no error, nothing. Let's load. Okay, I should, when I push on this red button, I should see a stop coming. Yeah, so you see now I do have a stop and the counter ready, but we don't have any counting for the moment. So that's the picture that we do have, and that's exactly what we need. So now we are going further to update the string and after that load it in the Nokia screen. Okay, so to update the screen we will need a few things to do. So the first one is we are going to check. So we are going to use now the function in help function. So the first one, we are going to check how many digits we do have. So I will add the last one. So even it's actually a short here, and we call it digit, and it will be equal to 0. Okay, and we will need, so actually, yeah, that's a good point to do. So we will need to have a string here that we will update. So let's put it here. So this is, we will put a string of 7 char. So char, we call it time, and it will have 7 char. And we will have another string of the number that we are going to input inside. So char number, and this one will be 3 position, with 3 position. Okay, good. So now we can jump immediately on this. So first thing to do is to check. So digit is equal, no, before digit we have to put the number, the second or the minutes. So let's add the minutes. Yes, so minutes or minute is equal seconds divided by 60. Yeah, it's divided, sorry. Okay, so let's first start by change. So int to char function, and we will change minute to input it inside number. Okay, and this is like the int char one is a little bit okay, so I should wait for this one. Okay, so now we are putting the number, transforming the number to a string. Okay, after that we take digit equal to the function of len str. Okay, and we are checking number. So this is a little bit special function, because when it was created I used it to get to use it directly in the index, so you have to put +1. Okay, and we need to check each time. So check if digit, so if it's equal to 1, or so if equal to 1, so if it's equal to 1, so let me make this one bigger to 2. So if minutes is equal to 1, I would like to add an extra 0 here. So this is what we are going to do. So if the length of my string is just equal to 1, what we are going to do, is concatenate string. We'll take time and we will put the string just 0. After that, we will add again the here in time, but we are going to add number. Okay, else, so if it's 2-digit, okay, if it's 2-digit, so we just concatenate and add this. Okay, and when we just finish this one, we have to put an strempty, or this is a function that will empty my string, so it will not add extra number as increment number. Okay, and final stop before we end and go to second, we have to add these 2 points here. So this is how we are going to build our string that we will after that send to the screen. So let's add here concatenate string, and we add the 2 points. Okay, oh sorry, I put in here. Okay, so we do have here now the whole function, and that will be exactly the same thing to be done for the next one, so which will be quite helpful if we bring directly all this to a function, so we don't need to do it again and repeat ourselves. So let me copy all this and go back to, let's make this one bigger, and we go back here. Let's create the function void, and let's call it digit check. Okay, okay, and we will check later what we will take inside it. We just put everything. Of course we will have this error, no worries, and let's put all the one here. So we do have number, time, and so first unsigned here, unsigned, so we don't have, so the digit we do have it, but int, so we do have the minute, so which is a kind of a time constant, so unsigned int time const. Okay, and after that we are going to use the char number, so we can put the same name, so we don't have any issue. And finally char time, which is this one. So the last two things is int here digit, even we don't need that much, and the last one is this one that we are going to change by time constant. Okay, so no error anymore, and let's take this one and copy it in the stopwatch, add here, of course gamma, and let's take it here. Okay, so let's bring this one here, and yeah, of course, so what I like here is when I put check and open, so my time constant one is minutes, and after that my number is just number, and finally my time is time. So it's quite intuitive and helpful to know how to input. We will repeat the same exercise, exactly the same exercise, but by changing here the minute to second. This will update our second. And for the last one, which is the we have to update the milli, which is, yeah, this is not millis but should be milli. So we are going to do it just manually because it's not that, okay, milli has not been declared, so I will declare milli as a quick let's call it as a short here milli. Okay, so milli here, and after that we are going to concatenate the milli. So first we need to put int to char, so transform milli to a char, which will be number. Then we are going to concat string, which will be time and then number. Exactly after that we have to strmt number, else it will keep increment. It's very dangerous to keep it like that. Okay, so now technically we have built our screen. So what we need now is just to print it in the screen. So in this situation, just before start writing the print, which is quite a much easier step, our counter or stopwatch is just going until 59 minutes. So what we need to do, after 59 minutes, if the number of minutes is bigger than 59, we have to reset to 0 again. And to do that, we can control this very easily using a if condition. So if minute is greater than 59, so it's if it goes to 60. Okay, so the condition that we are going to put is this. So we have to we just copy the reset. Let's make bigger. We go here and we just take the reset and we put the reset. Even we are not going really to reset it, but we have to come back to 0 and put in millis equal to 0. So even when we count, we go back to 0 again. Okay, else here comes the nice show. So we go like this, we align it, and here we are going to print in the same position, and we are, instead of putting something static, we are going to putting time. Okay, so with this step the time will be shown as we build it. And the last thing and very important thing, we have to not struct but strempty, we have to empty time, so when we build the next string on it, it will not overflow. Okay, so far should be enough. Let's check if there's any error or no warning. Looks good. Strange. Let's run. Okay, so let's push the bottom and check what happened. Okay, you can see that there is a timer working here, and it's quite fantastic because it works same as a stopwatch, and we do have some incrementation. So now we still have two steps to do. The first one is to put this one as a function, and also testing if the reset, if the overflow happen, is working properly. So first of all, let's check the reset. So instead of checking until 59 minutes, I will put if it's greater than 1 minute. So this one should reset when we finish the first minute and we go to the second minute. Okay, so let's save, run, and before just loading the code in the microcontroller, let's check to push reset here. Perfect. So we just have the option of start, and if we start, I do have an issue with the bottom, that's why sometimes I push twice. So you see that my stopwatch is keep running on time, and if I click again it stops, and I do have a star option waiting for me, and if I click again I have, sorry, this one stop. So that's really wonderful. This is exactly what we expected from the behavior of our stopwatch. Let's reset just for fun purpose and load. Okay, I hope that I saved. So let me start the stopwatch. Okay, and I will quickly, so as to that will spend 2 minutes and we would not have a very weird silence, I will cut until we get to the almost 2 minutes. Okay, so we got there. We still have a few seconds to wait. and then the we should see a refresh to 000 as we are putting yes, and you can see that we could restart our stopwatch without any issue. Perfect. So let's finish this tutorial by putting all this in a function. Let's call it SW, so we called SW stop, but we already used the SW start, so we will use the SW start func. So let's call it here. Let's bring the function here, so it's a void and SW start func. Okay, and inside we will find later what we need inside. So let's go here and copy everything. I think it should be fine. So this one is that one, so I don't need it. Okay, we put everything inside and we try to figure out all the red things. I guess, for example, so counter is needed, millis is needed, but milliseconds, seconds, minutes is really something that we can use there. So we can take all these ones here and input them here, so without any worries about that. So what we do have again that we need to confirm, so millis, so we will take all this one millis, so we need a millis, so millis is unsigned long, but I would like to take the pointer because I need to keep the value, and we call it millis. And after that, so counter to, so I need to take also counter is, let me check here, so it's a unsigned int, but I need to take it as here, and I really need to be sure that I'm taking the right one. So millis here is, we need to put it like this, and here to put it like this, and we should not forget the millis here, and should never put the counter itself as 0. So we do still have number and time, so as usual here it's a char of number and the other one a char of time. Let's check if, yeah, and a number have to be like this, so there is no red anymore, which is great. Let's put this one here and add it to our final program. Good. So let's quickly copy this and take it to the main program. Okay, fantastic. So millis will be passed as a pointer, and also for counter here, number will be passed as a number, and finally time as time. Okay, so let's check if everything looks good. Here too, everything seems to be good. Yeah, we don't forget that we need to be more than 59 minutes, and looks good. So let's save. You see that restarted so many times as it is only 1 minute, only 2 minutes actually. Load. Okay, so let's try to make a test. I'm not sure if I'm good enough to and fast enough to do it, but it's worth it to make a test. So I'm taking, let me put it showing as much as possible, and let's make this one big. Guys, don't judge me on this one, I'm trying to do my best with you. So let's put this one and start to run both together. Yeah, I need to hide this one a little bit, but let's start both together. Oh sorry, let's reset, so as we can do it. So reset, stop, reset. Okay, reset is not working. I think the bottom stop is working. Okay, we do have an issue here. We can't reset. Something is happening, so we can't reset when we do have this one. So we could go from here. So let's check. So reset, so reset function, and so reset is initially equal to 1. Let's check it again. Okay, so let's stop, reset, start. Okay, you see that the program is working in the wrong way. You see there is a counting which is not exactly we need to see, so something is not going well, and I'm quite sure I know the guilty person. So if we check here, this one, I was quite sure. So if you see really very strange behavior happening, means you are messing with the counter address, not the value. And this happens to me a few times, but that's worth to check it again. So let's run and check the behavior of the system now. Let's start, reset, working perfectly. Okay, stop. Oh, I reset it, sorry. Okay, so this is start and reset. Okay, so let me restart my stopwatch again, and let's prepare together. 1, 2, 3. Oh, I didn't push this one. Actually, I pushed it the wrong way. So stop. Sorry guys. It's okay. So reset. And okay, should be both are okay now. Yeah, you can see that we almost, it's quite hard to look at both together, but they are almost there. There's a small lag because my finger, but you can see that it's almost there. So congratulations, you can do your own stopwatch now. Thank you, and WeeW!